today? You gonna verbalize? You gonna send me?
I mainly just want to go over logs. That's my huge weakness. If you have any problems, you can come up with as well. And I have a few examples.
I got lots of stuff for logs.
All right, let me pull up something I can find. 1 second. Because logs are just like, I have to review them badly.
All right. Well, let me start. Before you give me problems, let me start.
Okay.
Before you can, hold on a second, I forgot about to do this. To understand, to understand logs, you have to understand this. For example, 8 equals 2 to the third. This is an exponential expression, not an algebraic expression. It is an exponential expression. Whenever you're talking exponential expressions, you're talking logs, because this equates to, what's the most important thing you have to remember to translate these from one to the other? And that's what you have to learn how to do, is translate.
Same bases.
What are logarithms? If you can answer that with one word, then you can never go wrong here.
I have no idea.
Logarithms are exponents.
Okay.
Okay. So if I'm going to write the logarithmic expression, the only thing I know for sure is that it's the exponent. Now I got to figure out where the b and the y go. Where do you suppose the b goes?
The b is gonna go on the right.
No, way down.
Or on the left. Yeah,
That's
it stays on the left.
Okay. And the only other place to put the y is the argument of the log. So those two expressions are the same. And you have to be able to go back and forth between them with equal ease. So tell me what the logarithmic expression of that would be.
Would it be log y or y log b?
Put it in terms of the numbers that I've written. 8, 2, and 3.
Then would it be 8 log?
Hold on. What you're doing is going from this format to this format. So, what's b?
Okay, b would be 2.
Okay, so we're going to put a 2 down there. What's x? Remember, logs are exponents. There's only one exponent. What's the exponent?
So that'll be 3.
Okay, and the only other number
is the 8.
So that is the equivalent expression. You have to remember this to go forward with logs. You just do. This is the most basic understanding of logs. And the most important thing is to know that exponential expressions always are going to involve logs. What is an exponential expression? Let me give you two functions. Only one of these is an exponential expression. Which one is it?
Y equals x squared, or the other one?
No. An exponential expression is when the variable is in the exponent. The variable is in the exponent right there. That makes it an exponential expression. And when you have exponential equations, you can't solve them algebraically. you have to use logs. That's the only way to go forward. So that is the definition of exponential, is where the variable is in the exponent. The variable there is in the base. Same with there, no variable there. So that is algebraic.
Got it.
Okay. Now, I've worked with enough log students that I know that everybody has to deal with the following 3 rules. Let's write them.
Okay.
This is something else you absolutely have to memorize. Both directions. They're going to ask you to do it both ways. In other words, they're going to ask you to do it from left to right. They're going to ask you to do it from right to left. Tell me what number 2 is.
So log A over B equals log A minus log B.
Exactly. Notice that we go from division to subtraction, just like we went from multiplication to addition. And this might be the most non-intuitive one. But nonetheless, it's true. What's that? Do you know what that is?
Log A to the B power.
That's what's on the left. What is that equal to? Remember, these are 3 identities that you have to know. There's no getting around it. You can get around some math rules, you can't get around others. You got to know all 3 of these identities. Okay, here's how I solve it. The B comes down and goes there, and it's equal to B times the log of A.
Okay, so it's B log A.
Let me give you an example. I'm going to write real little here because I don't have a lot of room. What's that equal to?
That will be 3 log A.
You're only applying this rule right there. I've got the log of 2 things being multiplied.
Yeah, 3 and 2.
Okay. So what's this equal to with our case?
Would it be 6?
No, log of 3. In other
Log of
words,
3.
3 is the A, 2 is the B.
Okay, so that's why they're adding.
What's the rest of it?
Okay, so it'd be log 3 plus log 2.
There you go. Okay. Now, let me give you an example here. What's that equal to?
So that'd be log 10 minus log 5.
Easy. Now, this one here. Now, there is one thing, is that for these rules to work, it has to be all the same base. In other words, if one of these logs is base 3 and the other is base 7, you can't apply these rules. You can apply these rules as long as the base is identical. It could all be base 7, it could all be base 3, it could all be base 10, it could all be natural log. But they have to be the same. Okay? So what's this the equivalent of? The bottom thing I wrote?
So it would be 4 log 3.
Now, log 3 is an irrational number, much like square root of 2 or pi. You can only get it in your calculator. Nobody expects you to know what log 3 is. Okay? So that's actually the most accurate answer. You don't want to put down, you don't want to look up in your calculator what the log 3 is and then multiply it by 4 and come up with a decimal. That is not the way to go in logs. It's a lot like radicals. At some point in math, you stop converting radicals to decimals. Same thing with logs.
So I just leave it how it is, so it's the most accurate.
That's the correct answer, yeah, if they were to give you this on the left. Now, let's just make sure you know how to go the other direction. Because they're going to ask you just as many of those questions as these questions. In other words, what we just did was going from left to right in every case. Okay? Now I'm going to give you some, and those are called expand. In other words, they will say expand the following log problems. And they'll give you something like the log of 3 times 2, like I gave you. But sometimes they will say compress. And then they might give you the log of, or they would give you the right side and not the left side. And you would have to turn the right side into the left side. So let me give you some of those. Tell me what this is.
Okay, so I got log 7 plus log 3.
That's what I've written on the right. Tell me what it is on the left. In other words, this problem, they would say condense it. Turn these two log things into one log thing.
So would I just multiply them?
Exactly.
So log of 21.
Exactly. Like I said, they're going to give you just as many problems going from right to left as they are left to right. So let's do another one. Can't make it always easy.
Okay, so log square root of 2 minus log.
Oh, yeah, okay, you're reading back to me what I wrote. Okay, what's the answer? In other words, if you're going from right to left, what is the answer based on this right there?
Okay, so it's going to be dividing.
Okay.
So square root of 2 divided by, I can't see what's left on the other side of the log.
Really? You can't see that minus, or you can't see that 2?
No, I didn't see the 2. So it's square root of 2 over 2.
Tell you what, do me a favor. You've got your GoToMeeting panel fully open, don't you?
Yes.
Minimize.
Oh, I just made it smaller. Now I see it.
That's what the problem is that when you have it fully open, it covers up that part of your screen. So
yeah, I got it now.
Yeah, you can always minimize it, and it gives you a bigger screen capacity.
Okay.
So thanks.
So, no problem. Thank you.
So it's square root of 2 over 2.
Correct.
And I made it that way on purpose. I didn't want to divide by an irrational square root of 2. And let me give you one more. That means the cube root of 13.
Okay. So 7 log cube root of 13. And so I'm trying to see what it would become.
I don't know if you can still see this. I've kind of covered it up with my writing. Get rid of some of the stuff over here. That is the log of a to the b power.
Okay, log a to the b power.
Yeah, that's the third rule. You need to memorize each of these rules. Every one of them. Know them like the back of your hand.
Okay.
So what does this turn into?
So would I have to like bring that cube root of 13 to the left side?
No. What you want to do, you want to take that b. See that b?
Yes, I see 7.
7. You want to move it to the exponent. So it becomes the log of the cube root of 13 to the 7th power. And now I can simplify that. How? How does that simplify?
Log 13 to the cube root to the 7th power. Would I take this 3 out of the 7?
Yeah, you multiply. In other words, when you are taking the cube root of 13 to the 7th power, first of all, if you convert that to 13 to the 1/3, same thing. And now you've got 13 to the 1/3 to the 7th power, you multiply the exponents. So it becomes 7/3. I made each one of these intentionally more difficult because it seemed like you were getting the concept. It's a simple concept as long as you know these 3 rules. You got to memorize. If you forget one of these rules, you're going to miss all those problems. Okay? Now, let me help you a little bit. Multiplication becomes addition, 1 level less. Division becomes subtraction, 1 level less. Exponentiation becomes multiplication, 1 level less. So you don't necessarily have to remember what all the levels are. You just have to remember that when multiplication's going on there, multiplication's never going to be going on the right side. They're never the same.
Okay.
All right. So hit me with your problems. We're ready to move on.
So the next one I have is, the question is rewrite each equation as requested. Okay. So the first one is, I have ln2 equals y, and it says rewrite as an exponential equation.
Okay. Here we're going back and forth between logarithmic and exponential. Again, it gets back to this basic problem. You have to remember how to go between those two. What's the logarithmic expression of that?
ln2 equals y. So that would be...
No, of this. Y equal b to the x. Give me the logarithmic expression of that.
Log or y log.
What are logs?
Exponents.
So what goes on the other side of that equation?
So would it be a 1?
Hold on. What's the exponent?
X.
Oh, that's always where you start. If you don't know where to start, start there. Now, what's the base?
I see b.
Okay, base is always b. Where's that leave the y? As the
front
argument. I call that the argument.
Okay.
Okay? So, always know how to go between there and there. Now here, they're giving you the logarithmic expression. And just for your information, in case you don't know, that is the same as log base e. Okay? So, this time, they're wanting us to go from this to this. they want us to put it in the exponential expression. So, what is the exponential expression of that?
Okay, so converting it to the y equals b to the x is what we're trying to do.
Yeah, exactly.
Okay. So,
Let me give you another little trick. Take the number on the far left, raise it to the power on the far right, and it equals the number in the middle.
so e to the y equals 2.
Exactly. So that is the exponential expression of that. Because all I did here was to write it so you would know what the base was. In other words, a lot of people are confused by natural log. Natural log is just log base e. E being another irrational number that's approximately 2.71. Happens to be maybe the second most important number in all of math. Right there, E.
Okay.
Okay, what else you got?
The next one I have is rewrite as a logarithmic equation, and it's e to the 7th equals x.
Okay. Without me rewriting that y equal b to the x, all of that,
Yes.
I'll do it one more time. This is always, if you get lost, this is where you have to begin. It really is. You have to know this part right here. There's the exponential expression. Logs are equal to the exponent. B is always the base. Y, that's the only place left for it.
Okay, so it'd be log e to the y equals 7. Would that be it?
7 is the exponent.
So would that be x?
So, no, 7 is the exponent. This is the most important thing to do first. One step at a time. If you don't understand it, just do it one step at a time. The logarithmic expression is always the log of something. We haven't filled that in yet, but the log of something equals 7. 7 is the exponent. That's why it's so important to remember that logs are exponents. Now, what's the base?
The base is e.
Okay. And there's only one other place. What goes as the argument?
Would it be y?
There's no y here.
X.
See, that's why it was a confusing problem. Is because they switched out, they didn't include a y, and they made x, where x would normally be y, they just chose to call it x. And that, you gotta watch out for that. But this, notice that I'm taking this, and I want to put it back into exponential expression. I take the number on the far left, raise it to the power on the far right. As long as you can do that, you know you've done it right. In fact, if you're unsure, always go backwards and make sure that you get exactly what you're supposed to.
Yeah, just break it down slowly.
Well, yeah. I mean, if it's kind of like foiling or I should say it's more like factoring. When you factor, if you want to check to see if your factoring is correct, then you multiply them back together again and see if you get what you started with. It's the same thing with logs. When you go one direction, oh boy. Hold on a second.
Okay.
Okay, I'm fine. What else you got?
Okay, the next one I have for you is, one second. Okay, so it says use the properties of logarithms to expand the following expression.
And then there's going to be a series of questions after this that say condense, correct?
It says your answer should not have radicals or exponents, and you may assume that all variables are positive.
Well, that's fine. But I'm
That's
telling
all
you
it
that they're
says.
going to give you as many problems to expand as they are condensed. This is just the first set. This is the expansion ones. So give me your first one.
Okay, so the first one is log parenthesis.
Hold on. Hold on. Going on here. All right. Okay.
Then divided by like a division sign inside the parenthesis.
What divided by what?
2 parenthesis x plus 7 parenthesis to the 5th power. Over cube root of x to the 4th. Unclosed parenthesis.
It's possible that I've got that 5 in the wrong place. Yeah,
Nope, that's how it
that's
looks.
exactly how it looks? Okay.
Yes.
All right. So we're going to have to use two out of the 3 rules here. Okay. When
Okay.
you are expanding, do the simple stuff first. By the simple stuff, I mean this bringing the 5 down in front, do that last. When you are condensing, you do that first. But when you are expanding, do it last. So let's just start by the fact that we have division going on. That means we have subtraction, right?
Okay.
So what are we going to subtract?
That'd be log 2 parenthesis x plus 7 to the 5th minus the cube root of x to the 4th, or log cube root x to the 4th.
Was there a... Oh, yes. Okay, I see. Let's write that better. How should we write it? Instead of cube root of x. In other words, radical signs aren't terribly useful in logarithmic expressions. You want to always convert them to exponentials because you can see the power of having an exponent. We get to bring that exponent down and multiply it. So we don't want radical signs. How can I write that? What is the cube root of x to the 4th?
4 over 3.
It's x to the 4 over 3, yes. That's a better way to write it. Okay, now we haven't fully expanded it yet. We still have one last step we can do, which is what?
I guess take out the log 2 or distribute it, or no?
That's not the most... No, actually, that you can't do that. Because notice the 2 is not being raised to the 5th power. The only thing
Just x plus
raised to the
7.
5th power is the x plus 7. So the only thing
True.
you can do immediately is to bring that over and stick it in front of the log function. That's rule 3. Okay? That's the most important one, actually. That's the one that's going to give you the most difficulty. So those two are identical. And I still have this. And now I suppose we can distribute that. So I suspect that if they gave you an answer key, it would be this. maybe they don't need you to do this last step, distributing that, but you know, when you can do something, do it. Not always. You have a quadratic that's already factored, leave it factored. But in this case, I would do everything I could. And now you can't do anything else with that.
Okay.
What else?
The next one I have is, are you ready?
Uh-huh.
Okay, so log, parenthesis, then have a square root sign over full division, or yeah, over like the whole entire division problem, I guess.
What's the numerator and the denominator?
It'll be parenthesis x plus 6 to the 5th power over x cubed. And then everything's closed in parentheses in the end.
I have that right?
Yes, you do.
Okay. So, they're obviously going to ask you to expand this.
Correct.
Get rid of that radical. Well, hold on a second. Yeah, let's get rid of that radical sign. How can I write this better? I get rid of the radical sign. That's step one.
I would have to cube it. I mean, not cube it, square it to get rid of the radical.
Convert it to a exponent. In other words, to get rid of radical signs, you got to figure out what the exponent is. When you have a square root sign, the exponent is 1/2.
1 over 2.
Yeah, if you have a cube root sign, it's 1/3. Okay, so if I want to get rid of that radical sign, the first thing I'm going to do is this. These are difficult problems, but if you just do them step by step, you can always get them. There, I've gotten rid of the radical sign. Now I have everything in exponents. Correct?
Yes.
Okay. So, when you are going the other way, when you're expanding, you got a couple of things you can do here. To be honest, when I have an exponent there, and I have an exponent there, and I have another exponent there, my first inclination is to condense it all. Let's simplify it. And I can absolutely do this. Now, instead of to the 5th, that's going to be to the 5/2, because I'm going to multiply that by that. And instead of to the 3rd, it's going to be to the 3/2. Okay?
Okay.
Because only the numerator was being taken to the 5th, correct?
Yes.
Okay, and the denominator was being taken to the 3rd. So this is definitely simpler than what we had.
Yeah, that's true.
Okay.
So I know that there's subtraction because I see the division.
Yeah, and notice that these exponents are different. So what's the next thing we should do? It's not all that obvious. Remember, we're breaking it down.
Yep. So log of x plus 6 and 5 over 2.
Good.
Minus log x to the 3 over 2.
Perfect. And the last step. In other words, that's never going to be the last step. The last step is always to bring that exponent in front.
In front. Okay. So that would be 5 over 2 log x plus 6 minus 3 over 2 log x.
There you go.
So you always want to bring those numbers, the exponents, to the front?
I usually do. It kind of depends. When I'm going to expansion, I don't. I do it as the last step. And
Okay.
when I'm condensing, I do it as the first step. That's the way my brain works, handles it the best. There's
Okay.
no priority. You can do it in any order you want. It's just how you think about it. This problem was a little bit strange. This was a fairly difficult problem. You had to know all three rules and all three rules well, and what a radical sign means in terms of an exponent, and how to handle double exponentiation. You have to know to multiply those two. And that half also applies to that 3. So there were a lot of things in this problem. But you end up always getting to the same answer.
Okay, I have another one. So it says write this expression as a single logarithm. So I have...
That means condensing. They're going to give you multiple log expressions, and then they're going to want you to write it as a single one. That's going from right to left.
Okay. So this one is 7 log to the base of c, and then a y, minus 1/3 log base c x.
Hold it. Log base c of x, okay.
Plus 5 log base c of y.
Okay. The first thing we realize is they're all the same bases. That means we can apply the rules of logs. If any one of them was not the same, we could not do it. Now, here we're going the other direction. And what did I say? I said usually I take the number out in front and move it to the exponent first. So let's do that.
Okay.
So what do we got?
So it would be log c y to the 7th minus log cx to the 1/3 plus log cy to the 5th.
Now use the rules of addition and subtraction to turn that into 1. Log c.
So, well, what I'm looking at is the log cy to the 7th is going to be over top of the rest of it.
The numerator.
Over...
No, there's division going on somewhere because of that.
Correct. So it's going to be over x to the 1/3.
And what about this?
Plus y to the 5th.
It's not plus, it's multiplying.
Okay, multiplying, so it'd just be y to the 5th.
Remember, you never do the same thing. They're
you're right.
added together now, so you cannot add them together when you
again
rules. Okay? Just always remember you got to do something different. And then that actually condenses to what?
And that would be condensed to y 35 over x.
Again, the same rules that apply to logs apply to exponents. You never do the same thing. I'm multiplying y by y. I am never multiplying those two exponents. What should I be doing to those two exponents?
Adding.
Yes.
So it'd be y12 over x to the 1/3.
Yep. The same rules. Remember, logs are exponents. So the rules that apply for exponents apply to logs also. Yeah, and probably the most important thing to know is never do the same thing. You got to do something different. Now, that doesn't necessarily mean you're going to get it right, but you always have to do something different.
Mm-hmm. I have another one where it's condensing.
Okay.
So it's 3 log base b of z.
Okay, hold on. 3 log base b
of z.
Okay.
Plus 3 parenthesis log base b of x minus 3 log base b of y.
In parenthesis or without?
No. The end parenthesis is going to be after this one.
What's the argument on this?
So it's going to be minus 3 log base b of y.
There's a 3 in front? Like that?
Yes.
Okay.
Yes. And then close parenthesis. Yep.
So that's what we're condensing.
Correct.
What do we do first?
Okay, so first I want to bring all the numbers from in front to the exponent position.
Yeah.
So it's going to be log b of z to the third.
Hold on a little second for that. I realize that's going to give us a problem. Let me show you what the problem is, and then let's talk about a better way to do it.
Okay.
So this is what you would do. What would the rest of it be?
So I should distribute the 3.
That's the correct way to do it. If you do it by moving up the first 3,
that'll mess it up.
Well, then we have a problem. Then we have to cube that. Okay? And that's not going to be easy to cube. That's a lot of algebra. So, is there a better way to do it? Yeah, it's to distribute the 3 first. So we have 3 log base b of x minus 9 log base b of y. Now we can take each of these terms, and I can take this 3, move it up to there, right?
Yes.
Take that 9, move it up to there.
So now I have those.
Now we're ready to put it into a single log expression.
Okay, so
What goes in the numerator?
z cubed times x cubed
Goes in the denominator.
divided by y to the 9th.
Perfect.
And I'll leave it at that, since there aren't any like terms. And I'll leave it at that, since there aren't any like terms.
You can't really do anything to that. There's nothing, you can't really simplify that. I mean, you could write this as z x to the 3rd, but that's not a simplification that's needed or necessary. It just happens to be identical. If you were picking from multiple choice, that might be your answer. So always know that. But okay, what else?
Okay, I have another one like it. So 7 log base 7 parenthesis 8z plus 1 close parenthesis plus 1/4 log base 7 open parenthesis z plus 4 then close.
That's it?
Correct.
Okay. We're condensing. What do we do first? There's nothing unusual about this. In other words, this is kind of a classic simple problem, as opposed to the last one, which required an unusual first step.
Yeah, the distribution. So for this one, I'm going to move the 7 to the exponent, so it'll be log base 7, 8z plus 1 to the 7th. Then it'll be log 7, z plus 4 to the 1/4.
Now what?
So then I'll have log base 7 parenthesis, and then it'll be 8z plus 1 to the 7th times z plus 4 to the 1/4.
Yeah, you have to use double parentheses here.
Since there's parentheses up.
Yeah,
that are there, period.
You certainly don't want to have to take that binomial to the 7th power. So, which you could do, but there's no need to. And that's just coincidental. That's kind of Trying to get them to fool you a little bit. There's no rule. There are a couple of other rules. Let me just go over them before we run out of time.
Okay.
It's worth knowing.
That's for sure.
What's that?
So log base 13 to 1, so it'd be 1 log base 13.
No, what is that? So translate it to exponential. What would you do?
Okay, so right now I don't have any exponents.
Let's call that x. Okay?
Okay.
So if I transfer it to exponential, what does it become?
A 1.
No, give me the exponential equation. I want you to be able to get really good at going back and forth between logarithmic equations and exponential.
Oh, the two equations.
Yes.
So it would be log base b y equals x.
We're going to exponential. When you go to exponential, you lose
Y equals bx.
There's no y. Start with the number on the far left, 13. Raised to what?
To 1.
No, logs
Or
are
x to
exponents. X has to be the exponents. Logs are exponents. That has to equal 1. Well, what is x? What's the only value for x where this is a true equation?
0.
Exactly. So the log of 1, no matter what the base, is always 0.
0.
Yeah, in other words, if I'd have said the log base b of 1 equals x, x has to be 0, no matter what the base is. So that's worth knowing. Another one worth knowing is this. The log base b of b, we'll call that x. Okay? What's x?
Okay. So
if you don't know what it is, convert it to exponential.
Okay, so as far as the exponential form, it would be log base b of b equals x. So would I put b to the x equals 1?
No, there's only one
Or no,
there.
equals b.
There's no 1 anywhere. Now, what does x have to be for that to be true?
1.
Exactly. So the log base b of b is always 1. So if I said the log base 17 of 17, I know instantly that's 1. I don't have to look it up in a calculator. And there's one other rule that, just given the level of difficulty that you've shown me at this point, they're probably going to give you problems like this. If you have the log base b to b to the x plus 1, what's that equal to, do you think?
Okay, so it would be b to the x plus 1 equals b.
Yeah. So what's the answer? Well, hold on a second. Let's back up. Not sure exactly where we went wrong here. Here's what I'm trying to point out. If this is the same as the exponent raised to another exponent, then your answer is that. In other words, if I said, what is the log base 13 of the number 13 raised to the x squared power.
It'll be x squared.
Exactly. So look for these things where your base is the same as one of the numbers. These rules are not as important as the first three that we covered, but
Okay.
I suspect you're going to run into it. And it's really worth knowing. So let me just test you a little bit on some of these that I just covered. Hold on. Is that equal?
Log base 17 to 17. So that
The
would be
way you verbalize that is log base 17 of 17. In other words,
okay.
if you stick an of before the argument, it makes it, at least that's the way I verbalize it. I'm not positive that teachers do it, but that's the way I verbalize it.
So it'd be 17 equals 17.
This is a rule. You're gonna recognize that that's the same as that. So
Yeah.
this has a special answer that's usually either 1 or 0.
So it'd be 1.
Exactly. Because you know that 17 to the 1 power equals 7.
It'd be 17.
Yeah.
0 would be 1.
Okay, so that's that rule. Let's do this one here. Log, let me think for a moment. Base E, and I'll write it like that as opposed to ln, but it's important to know that that's what ln means.
Okay, ln means log base
It
E.
means log to the base that is the number E. E is a number like pi. It's irrational. The only way to describe it is E.
Okay.
Okay. So if I said, all right, so I'm just going to write it like that. Instead of like that. Let's not use that. You'll never see that. I just did it for purposes of explaining that that's what ln is it's log base E. Okay.
Okay.
Is that equal to?
So that would be E to the x squared.
No.
E.
There's two ways to do this. Let me go through both of them.
Okay.
First of all, bring that down in front. Okay? So this is the same as x squared times the natural log of E, which is the same as x squared times the log base E of E. Well, what's that equal to?
What is log base E of E? 1.
Exactly. So what's this answer?
So it would be x squared, or log base E of E equals x squared.
In other words, if this is the same as the base, then the answer is whatever that is. In this case, it's x squared. So you don't have to do this in 2 steps. This is a 1-step problem. It's like if I said, what is the log base 117 of 117 to the x cubed power? What is that?
That'd be 1.
The x cubed. This part is 1.
X cubed.
That
okay,
part is 1. But remember, the x cubed comes down in front and multiplies by that. So you don't need to do it in 2 steps. Like I said, the answer is always the exponent, whatever that exponent is. If that exponent was plus x minus 17 like that, then that's the answer.
Really?
Yeah. Whatever
Okay.
that exponent is. If you're talking about a log that is the base that matches the argument, then the answer is whatever the exponent of the argument is.
Okay.
All right. Now, we've covered every log rule. And if you
I just have to
want to get
study
this
then.
down pat, I would review this session. I'll have it uploaded by tonight for you.
Okay.
And
Thank you.
just go through each of there's like going from exponential to logarithmic. You got to remember that. And then you got your 3 basic rules of logs. And then you have your 3 other rules that are similar. Like, one thing I didn't cover was this one. I can't remember it. I don't want to lead you astray.
It's okay.
There's a third one where the exponent is the log. I have to think about that before I give you that information.
Okay. I'm probably going to meet with you again tomorrow. I'll probably schedule something tomorrow.
Okay, I tell you what. Can we do that little experiment right now?
Yes.
Go ahead and go to Digital Math Tutor.
Okay.
Schedule something for tomorrow. And pick any time. And it doesn't have to be the time you need to know right now. You can cancel it. You know, the way to cancel a session is to just go to the confirmation email, and there's a cancel link on there.
Okay.
So if you need to change a session, make your new appointment, and then go back to that first confirmation email and cancel your first appointment. That's kind of the cancel and replace. But yeah, let's just make sure my Gen book calendar is working correctly here.
Okay, I'll try it right now.
Yeah, pick some time tomorrow that you think might work. And like I said, you can always change it.
Okay.
It's just make sure that it's working right.
Yeah, it looks like it worked this time. I picked tomorrow at 2.
Yep, just came through. Great. You want me to leave that there unless you change it?
4 o'clock would work for me. Yeah, I'll leave it there.
Leave it at 2? Okay, that's 4 o'clock.
Yeah, 4 o'clock my time.
Great. All right, Taylor, we'll talk to you tomorrow.
Okay, sounds good. I'll talk to you tomorrow, Mr. Cowan. Thank you for the help.
Sure.
Have a good evening. Bye-bye.